Let's practice solving linear systems by the method of elimination. While in some previous videos, we've gone over solving systems by graphing as well as substitution, in this particular video, we're going to be focusing on solving these systems by using elimination. Real quick, before we get started on solving these problems, if you'd like to download a free blank copy of this PDF, you can find a link in the description box below. And you can also find an annotated or answer key PDF there as well. Alright, so let's get started now. So first off, for number 1, we have the equation 6x plus 5y equals 19, and 2x plus 3y is equal to 5. To use the elimination method to solve this system, we need to either get the coefficients for x to match or be opposite, so the 6 and 2, their LCM, or the least common multiple for 6 and 2, would be 6, since 6 times 1 is 6, and 2 times 3 is 6, or you can either choose to make the y coefficients match. So 5 and 3, their LCM is going to be at 15. So totally your choice if you want to make the y's match at 15 for their coefficients, or the x's match at 6 for their coefficients. Now my preference is going to be to get these coefficients for x to match here, so we want to make sure we know when 6 and 2 meet for the first time. So they're going to meet at 6. To do that, let's say 6 is the first multiple of 6, so I'm going to multiply the whole top equation by 1. If we go ahead and do that, we're going to get the equation 6x plus 5y is equal to 19. Okay, so that equation basically remains unchanged. And then for the second equation below, let's say 2 times 3, the third multiple of 2 is going to be at 6. So multiplying the whole second equation by 3, we're going to get 6x plus 9y, and that's going to equal 15. Alright, so now that we have these rewritten equations, let's see if we can solve this system by elimination. Now keep in mind, we did get these 6x's to match here, so if we're going to use elimination, we should go ahead and subtract these two equations from each other, since 6x minus 6x is going to get eliminated, which is the whole point of this method. Alright, then 5y take away 9y. 5 minus 9 is going to be negative 4, so we're going to get negative 4y. And that's going to equal 19 on the right side. 19 minus 15, that's going to equal a positive 4. Go ahead and write that. One final step to solve for y, let's go ahead and divide both sides by negative 4. Dividing both sides by negative 4, we're going to find out that y is equal to negative 1. Now that we know what y is equal to, you can either substitute it into the second equation here, or we could substitute it into the top equation over here. Totally your choice. Now I'm going to choose to substitute it into this second equation here. So I'm going to say this is 2x plus 3 times y. We think y is negative 1, so let's go ahead and plug that in, and that's going to equal 5. All right, so we only have one variable here. If we multiply 3 times negative 1, that's going to be negative 3. So instead of writing 2x plus negative 3, I'm just going to write 2x minus 3. It's the same thing, is equal to 5. Let's go ahead and solve this two-step equation now, add 3 to both sides. If we go ahead and do that, we're going to get 2x is equal to 8. And then finally, let's divide both sides by 2. Dividing both sides by 2, we find out that x is equal to 4. So the solution for this system of linear equations is going to be 4 comma negative 1. So these two linear equations would intersect over in quadrant 4. Now let's go ahead and just check our solution here. So here's x and here's y. We can check it first by substituting these values into the top equation to see if it's true. And so if we do that, we're going to get 6 multiplied by, let's see, 4. Go ahead and put 4 in there, and then plus 5y. 5 multiplied by negative 1, and we're going to see if this is equal to 19. Okay, 6 times 4 will be 24. 5 times negative 1 is negative 5, so we're going to get 24 plus negative 5, and 24 plus negative 5, you got to ask yourself, does that equal 19? Just to really check, and it does equal 19. So since 19 does equal 19, then we know we did a good job here. So we know it works for the first equation, so let's just check in the second equation here. So we have 2x, which is really going to be 2 times this 4. And then we're going to go ahead and add 3 times y. Y we think is negative 1. And hopefully this is going to equal 5. All right, cool. So on the left side here, let's go ahead and multiply 2 times 4 is 8. 3 times negative 1 is negative 3. So 8 plus negative 3. Hopefully that's equal to 5. And pretty sure that is true. So 8 plus negative 3 is just 8 minus 3, so 5 does equal 5. So we know that our answer does work here. Here's number 2. For number 2, we have this system of 7x minus 6y is equal to negative 1, and 5x minus 4y is equal to positive 1. So again, just like the last example, we can either figure out when 7x and 5x meet for the first time. I think their LCM, since they're relatively prime, is going to be at 35. So we could multiply the whole top equation by 5 and the whole bottom equation by 7 to get you 35x and 35x. Or we can figure out when 6 and 4 meet for the first time. 6 and 4, I think they meet at 12 for the first time, right? So 6 times 2 is 12 and 4 times 3 is 12. I think that's going to be some smaller numbers, so I'm going to go ahead and use those, right? Totally your choice though, whether you want the x's to be eliminated or the y's. So let's go ahead. I'm going to decide to eliminate the y's here. So I'm going to multiply the whole top equation by 2. That way we get negative 12y. I'm going to take the whole bottom equation here and multiply it by 3. Okay, so if we multiply the whole top equation by 2, we're going to get 14x minus 12y, and that's equal to negative 2. And then for the bottom equation, 3 times 5x, that's going to be 15x. Then negative 4y times 3, it's going to be negative 12y. You can see these coefficients for y match, which is what we're looking for here. And then 1 times 3 is going to be 3. Okay, so notice that we do have these matching y terms, which is good for us. If we subtract the same things, we should get 0, right? So don't add them. If you add them, you'll get negative 24y, and they won't be eliminated. So 14x take away 15x, that's going to be negative 1x, or just negative x. And then we're going to see here that negative 12y minus negative 12y ends up being 0y, so it gets eliminated. And then this negative 2 take away 3 is the same thing as negative 2 plus negative 3, and that's going to equal negative 5. Finally, we can go ahead and divide both sides of the equation by negative 1, or we can multiply both sides by negative 1. Either way is fine. Either way, we're going to see here that x is going to equal positive 5. Okay, so now that we know what x is equal to, let's go ahead and either substitute it into the bottom equation or the top equation to solve for y. Totally your choice. I'm going to go ahead and substitute it into the top equation this time, just to kind of mix it up here. But we know x is 5, so this is going to be 7 multiplied by 5. Go ahead and substitute that 5 in here. And then we have minus 6y, and that's going to equal negative 1. If you want to substitute it into the bottom equation, go ahead and do so and see if we get the same thing. 7 times 5 is going to be 35. So we're going to have 35 minus 6y is equal to negative 1. Then we just have a two-step equation. So let's go ahead and subtract 35 and subtract 35 from both sides here. If we do that, we're going to end up with negative 6y is equal to negative 36. And then we can divide both sides by negative 6 here. If we do that, we're going to get y is equal to positive 6. That would be the y value for our solution. Putting our x and y value together, we have this ordered pair for our solution of 5, 6. So we know that if we graph these two linear equations, they would intersect in quadrant 1 at this location. Let's go ahead and check to see if our solution does work for both equations. So let's go ahead and take this solution of 5, 6 and substitute it into that top equation. So 7 multiplied by this 5 minus 6 multiplied by 6. We're going to see if this is equal to the negative 1 that's on the right side of the equation, right? So if we do 7 times 5, that's 35. 6 times 6 is 36. So we'll have 35 minus 36, and that should equal negative 1, hopefully, right? 35 minus 36 is negative 1. So since negative 1 does equal negative 1, this is a true statement. So we should feel good about that one. And then plugging in our solution into the second equation, we're going to get here 5 multiplied by 5 minus 4 multiplied by 6. And we're hoping that this is just going to equal the positive 1 that's on the other side here, right? So 5 times 5 is 25. 4 times 6 is 24. So we're going to have 25 minus 24. And we are looking for that answer of 1. Now 25 minus 24 is equal to 1. 1 equals 1, so that is a true statement. So we know that our answer of 5, 6 here does check out in both situations. Here's number 3. For number 3, we have this equation of 4x plus 5y equals 35, and 2y is equal to 3x minus 9. So this first equation is already in standard form, which we do like. The second equation over here is not, so maybe we'll do some rearranging there first so that we can get them both in standard form. Okay, so the second equation here I'm just going to copy down as 2y is equal to 3x minus 9. To get this to be in standard form, let's go ahead and take away 3x from both sides of the equation here. If we take away 3x on both sides, we should end up here with negative 3x plus 2y is equal to negative 9. Okay, so now we have this top equation that's in standard form, and we have this bottom equation that's also in standard form. Okay, so I'm just going to go ahead and highlight those two real quick. So we have this top one over here, and we have this bottom one over here, and these are the ones that we're focused on. Now, if we're going to use elimination, we need their coefficients of x's to match. So when do 4x and negative 3x meet for the first time? Negative 12 would be their LCM, so we could use negative 12. Or we could go ahead and figure out when 5y and 2y meet for the first time. Now 5 and 2 meet at the first time at 10. So really up to you what you want to do there. I think I'm going to go with eliminating the y's. I think just multiplying by 2 and 5 are a little bit easier for me. So I'm going to go ahead and take this top equation, and I want to get 10y. So I'm going to multiply the entire top equation by 2. If we go ahead and do that, let's see. 2 times 4x, that's going to be 8x. And then 2 times this 5y is going to be a positive 10y. And then 2 times 35, that's a little bigger, but that's going to be 70. All right, what about the other equation? If we want to get 10y, let's take this whole equation here and multiply it by 5. Okay, so negative 3x multiplied by 5 is going to be negative 15x. Then 2y times 5 is going to be positive 10y. And then negative 9 times 5 is going to be a negative 45. All right, so let's go ahead and solve the system here. Notice that we do have these matching 10 and 10. So in order to get rid of those or eliminate them, we should subtract them. Okay. Now 8x, take away a negative 15x, that becomes 8 plus 15x. That should equal 23x. And then if we go ahead and take that 10y minus 10y, those y's will get eliminated. And then if we take this 70 and we take away a negative 45, that's just 70 plus 45, that's going to equal 115. All right, so one-step equation here. Let's go ahead and solve it by dividing both sides by the coefficient, which is 23. And we should get here x is equal to 5. Let's take this x equals 5 and use it to help us find out the y value. Now I'm going to use the bottom equation. I just think it's a little bit easier since y is almost already isolated. So let's go ahead and plug in 5 for x into this second equation here. So we have 2y, and that's equal to 3 multiplied by x. We think x is 5. And then we're going to go ahead and take away 9. Now 3 times 5, that's equal to 15, right? So we have 2y is equal to 15 minus 9. And 15 minus 9, that's equal to 6. So we're going to get 2y is equal to 6. And then it's a one-step equation, so we can divide both sides by 2. And we get here that y is then equal to 3. So we know x and y, so our solution here is going to be at 5, 3 over in quadrant 1. Now this 5 is x and this 3 is y. Let's go ahead and just check this real quick. So take our solution and just verify that it works for this top equation. If we check this, is going to be 4 multiplied by x, which is 5 we think, plus 5 times y, so that's going to be 5 multiplied by the 3 that we got, 5 times 3. And we're going to hope that this is equal to 35 on the right side of the equation. So 4 times 5 is 20, 5 times 3 is 15, so we're going to get here 20 plus 15. 20 plus 15, is that 35? Well, yeah, I think so. 20 plus 15, that is 35. So we can say 35 does equal 35. And so it does work for the top equation. Finally, let's go ahead and just check this solution into the second equation just to make sure. So this is going to be 2 multiplied by y. We got 3 for y, so 2 times 3. Let's see if that's going to be equal to 3 times x, which we got was 5. And then let's go ahead and take away 9. Okay, so let's see if this is true. On the left side, this 2 times 3 is 6. On the right side, 3 times 5 is 15. So we're saying, is 6 equal to 15 minus 9? That's kind of the question, right? 15 minus 9 on the right side is 6. So since 6 does equal 6, then we know that this solution also works for the second equation. Here's one final practice problem. For number 4, we have the equations 3x minus 7y is equal to 5. That one's already in standard form. We have your x and your y and your constant. But then the second equation, we have 9y is equal to 5x plus 5. So that's not in standard form. So let's go ahead and just rearrange this equation on the bottom a little bit here. So let's take this 9y is equal to 5x plus 5. Let's go ahead and move this into standard form by putting the x's and y's on the same side. So take away 5x and take away 5x on both sides here. And if we go ahead and do that, we're going to get negative 5x plus 9y is equal to 5. So our top equation, remember, was already in standard form, so we're just leaving that one alone. And then our bottom equation, we just rewrote into standard form like this, right? So that's kind of the first step we gotta have to do. And then let's see if we can make these coefficients match either for the x's or the y's, depending on which one you want to eliminate. If we take a look at here, we have 3 and -5, so they're relatively prime, so we can make these match at 15 for the first time. That would be their LCM. If we want to make the y's eliminate, we'd have to see when 7 and 9 meet for the first time. They're also relatively prime, so they would meet at 63, which is a much higher number. So now I'm going to go with eliminating the x terms here just because the LCM of their coefficients is 15, as opposed to the LCM for the y coefficient is at 63. So I'm going to go ahead and eliminate these x terms first, right? So let's go ahead and multiply this whole top equation by 5. 5 times 3x is going to be 15x, and then 5 times -7y is going to be -35y, and then 5 times 5 is equal to 25. So that's that top equation. For the bottom equation, let's go ahead and make this have a coefficient of 15 or -15. So let's go ahead and multiply this whole bottom equation by 3. If we go ahead and do so, -5x times 3 is going to be a -15x, and then 9y times 3, that's going to be a +27y, and then 5 times 3 is equal to 15. Okay, so let's go ahead and solve this system here. Notice how we got these coefficients to match here, which was part of the plan. However, we do have opposites, right? One's +15, one's -15. So don't subtract these. Instead, we're going to add these two equations together. If we add a +15x and a -15x, that would cause them to eliminate, which was the whole goal here, right? Next, we have -35y plus 27y, and that's going to equal -8y. And then on the right side, we have 25 plus 15, and that's going to equal +40. We have a one-step equation here to solve for y. Let's divide both sides by -8. If we go ahead and do so, we're going to get y is equal to -5. Now that we have our y value, let's go ahead and see if we can use this information to solve for our x value. I'm going to go ahead and plug it into this top equation. Feel free to do the bottom one if you would like. Substituting this in, we're going to get 3x minus 7 multiplied by this -5, and then that's going to equal 5 on the other side. Okay, this 7 times -5 is -35, but instead of writing 3x minus a -35, I'm just going to write 3x plus 35, and that's going to equal 5. Solving this two-step equation, let's go ahead and take away 35 from the left side and the right side. If we go ahead and do that, we're going to end up with a one-step equation of 3x is equal to -30. One more step, let's go ahead and divide both sides by 3 here. If we do that, we're going to get that x is equal to -10. That means our solution here is going to be at -10, -5. So these two linear graphs would intersect each other over in quadrant 3. All right, one final time, let's go ahead and check our solution. So we think x is -10 and y is -5. Let's check it one time by plugging into the top equation, and then we'll check it in the bottom equation as well. So 3 multiplied by -10 here, that's what we found out was x, minus 7 times this -5. Let's see if that's equal to the 5 that's on the right side of that top equation. Now 3 times -10 is -30, and then 7 times -5 is -35. So we're going to get -30 take away, or I guess we can add +35, right? We can add the opposite, and that should equal 5 here. Now -30 plus 35 does equal 5, so since +5 equals +5, this checks out for that top equation. Now just checking this one final time into this bottom equation here, let's go ahead and say we have 9 times y. Y we got was -5. So 9 times -5 is hopefully equal to 5 multiplied by -10, and then plus 5. So let's see if this is true, right? On the left side, 9 times -5 is -45, and then 5 times -10 is -50. So we're going to get -45. Is that equal to -50 plus 5? -50 plus 5 on the right side is -45. So we can say -45 does equal -45. And so this does check out one final time. All right, so there you have 4 different practice problems on solving linear systems by using the elimination method. In this particular set of practice problems, we had to multiply the equations to get their coefficients to match. If you wanted to try some practice problems where you didn't have to do that first, where you just have to start by adding or subtracting, you could check out one of my previous videos. If you found the video helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.